Everyone thinks a global catastrophe will come from Earth. They're catastrophically wrong. The real danger isn't lurking in the deep ocean or buried beneath ancient ice. It's 93 million miles away, burning fiercely, constantly. Our own sun, giver of life, holds the power to unravel our technologically dependent world in a single, fiery breath. For nearly 2 centuries, we've lived under this sword of Damocles, mostly unaware. But the threat is not hypothetical. In 1859, the sun issued a stark warning, a global event that, if it happened today, would plunge us into an unimaginable dark age. This was the Carrington event. On September 1st, amateur astronomer Richard Carrington observed an unprecedented flash on the sun's surface. Just 17 hours later, the Earth was engulfed by a geomagnetic storm of staggering intensity. Telegraph wires around the world spontaneously burst into flame, shocking operators, and in some cases, allowing messages to be sent even with batteries disconnected. Auroras, usually confined to polar regions, were seen as far south as Cuba and Hawaii. Imagine that, a natural light show so powerful it painted the night sky red and green across the entire planet. But what was a curiosity then would be an existential crisis now. Our modern infrastructure is a fragile web. A Carrington-level event today wouldn't just affect telegraphs. It would send surges through our vast electrical grids, frying transformers, causing cascading blackouts that could last for months, even years. Water pumps, fuel lines, communication satellites, all vulnerable. Think about it, no internet, no GPS, no refrigeration, no working ATMs. Hospitals would struggle, supply chains would collapse. It's not just an inconvenience, it's a regression to a pre-industrial era, but with 8 billion people who depend on industrial systems. The science behind this unseen threat is complex, but fascinating. Solar flares are powerful eruptions of electromagnetic radiation. Coronal mass ejections, or CME, are massive expulsions of plasma and magnetic field from the sun's corona. When a CME hits Earth's magnetosphere, it can induce powerful currents in long conductors, like power lines. These geomagnetically induced currents, or GIC, are the silent destroyers of our electrical infrastructure. And the sun is cyclical. Every 11 years, it goes through a period of increased activity known as the solar maximum. We're currently heading towards the next solar maximum, projected for 2024-2025. The risk is increasing. So what are we doing about it? The first step is better prediction. NASA and NOAA operate a fleet of spacecraft constantly monitoring the sun. Missions like the Solar Dynamics Observatory, or SDO, provide real-time data. The Parker Solar Probe is literally touching the sun, gathering crucial data about the solar wind and CMEs at their source. Understanding these phenomena allows us to forecast space weather with greater accuracy, giving us precious hours of warning. This warning time is critical. It allows utilities to take preventative measures, temporarily disconnecting transformers, rerouting power, or even shutting down parts of the grid. It's a delicate dance, balancing risk with the need for continuous power. Governments are also developing resilience strategies. The United States, for instance, has a national space weather strategy. It calls for better understanding, enhanced preparedness, and improved response capabilities. One key solution is hardening the grid itself. Investing in more resilient transformers, developing quick deployment spare parts, and creating microgrids that can operate independently are all part of the long-term plan. It's a massive, expensive undertaking. But the threat extends beyond just power grids. Our satellites are equally vulnerable. A strong solar storm can damage sensitive electronics, corrupt data, or even knock satellites out of orbit. Imagine losing GPS, satellite TV, or global communication networks. Even our astronauts in low Earth orbit or beyond face radiation risks. Shielding and careful mission planning become paramount during periods of heightened solar activity. Space weather isn't just an earthly concern, it's a cosmic hazard. So while the sun continues its fiery dance, humanity is slowly, painstakingly preparing for its next grand performance. It's a race against time, a testament to our ingenuity, and a stark reminder that even the most fundamental elements of our universe hold hidden dangers. The unseen threat from our own star is real, but so is our determination to understand, adapt, and ultimately endure. Our future may just depend on how well we listen to the sun's ancient, powerful voice. Subscribe to uncover more untold stories and groundbreaking science from the cosmos.